So kicking off the 2019-2020 school year. So we're going to cover on Tuesdays, we're going to cover troubleshooting methodology. So I thought the best way to start would be to go over tech method. So what tech method is, it's back from a guy I wrote a book back in 1988. And all it really is tech method is a way of staying disciplined when you go out and troubleshoot a piece of equipment. So there's four major components to a refrigeration system. It's the compressor, it's a metering device, it's the evaporator, and it's the condenser. So really what this is touching on is kind of those four major components and the things that are involved with that. So when you guys are dealing with tech method, you guys just need to understand is like when you show up on a job and you check into that job and you're trying to find out what's wrong with that job, first of all, you need to have the right tools. So we're going to cover some of the tools that I carry in just troubleshooting. So I'm not talking about the actual repair that's being made. What troubleshooting is actually identifying the problem or problems going on with the system. And so the most important thing I can tell you about following tech method is you're doing the same troubleshooting every time. Your brain's logging those conditions in that refrigeration cycle, and what you'll find over time is that you become better and better and quicker and more accurate about your troubleshooting methodology with any types of refrigeration or HVAC equipment. Because even HVAC equipment is just a refrigeration cycle. So inside of that HVAC piece of equipment. So it doesn't matter if you're dealing with a heat pump, doesn't matter if you're dealing with an ice machine, doesn't matter if you're dealing with frozen beverage, doesn't matter if you're dealing with a rack system, it's the same steps. And so that's what we're going to cover. So the only time that you wouldn't get into something like this is if you were doing, hot side or food service equipment. There would be a different, but once you train yourself how to do tech method and to follow those steps, what you'll learn is you'll do that with every piece of equipment you come up on. You'll learn to identify certain things within that piece of equipment that you always need to check, and that you'll run that play every time. And that consistency is what creates the effectiveness and the efficiency of how you troubleshoot a piece of equipment. So a couple things is, guys give me a lot of flack about my man purse, but this is a little bag I carry on every job. So all it has in here is just my troubleshooting tools. So what I have in here is I've got a multimeter, amp clamp. I've got my Pro Rs, which are my Bluetooth gauges and temp sensors. So if you guys can't afford a set of Pro Rs because they're not cheap, so stubbies, a set of stubby gauges. So remember, they call them charging hoses or a charging manifold. Like you don't want to use a 6-foot hose manifold to do your troubleshooting. That's for repair or charging or that type of stuff. You want to have a set of stubbies. So you got your 7-in-1 nut driver. So every single size is in that one nut driver. So you've got your multi-tool, okay? Yeah, I've got a DIN screwdriver for the small control wires. So I've got a pair of strippers. I've got a Sharpie. I've got a couple rolls of tape, a couple crescent wrenches, and a service wrench. So notice that I do not have channel locks in here, okay? Couple things about me for you guys that haven't attended my classes. So caps and screws, put them back. If it's missing a cap or a screw, grab one out of your bag and put it back in the hole that it came from. Do not leave caps and screws missing in my machine rooms or on my roofs. So I do not like to see missing caps and screws. So missing cap is a leak, a missing screw is a hole in the roof. It went somewhere. Somebody pulled it out at some time. So I can't tell you how many cans and buckets of stuff that I pulled off of roofs. The guys have pulled the screw out, and they pull 10 out and they put 3 in. Right, big windstorm comes up, pulls the panel off, takes off the hood of a car. So second thing is you want to make sure is like do not get on a service or king valve with a pair of channel locks, or do not get on a service valve. Don't take the cap off with what you can take it off with if it's one of those type that have the channel lock, the rib, you can use a pair of channels to pull the cap off. You'd never, ever, ever touch that service valve with a pair of channel locks. Okay, I don't even want you guys to touch it with a crescent wrench. I want you to have the 2 sizes of service wrenches in your bag, just like I showed you. I'm troubleshooting all my stuff with that, right? That's what I carry.
Here's a funny story, a little side story about those king valves with some channel locks. This goes back to the Jensen days when I was there. He was very adamant about not using that. And he said if you go out there and he comes out there and he finds that you're using those, or if they're stripped, the last technician out there is going to be out there with a filer squaring that back up for the next size for the service tool.
Yeah.
You got to use.
The problem is you get out there in the middle of the night, you can't get on that service valve, and you've got a problem, and you got to get on it fast. Like there's nothing that makes you madder than not being able to get your service wrench on a king valve. So, okay, so that's kind of what I carry, and that's what I've learned to carry over my span of doing troubleshooting. That covers it, you know, at least 90% of the time. Obviously, there's some specialty situations where I'm dealing with a specialty piece of equipment, then I might need a set of Allen wrenches or something. But that's what I've been able to fit in there to troubleshoot the piece of equipment, not to make the repair. When I start to make the repair, I need vacuum pumps, I need bigger pieces of equipment, I need multiple trips out to the truck. That's when I go and I make my repair. So what TED stands for, it's an acronym for temperature, evaporator, this is compressor and condenser. And then heat loads. Okay, we're going to cover the T and the E today. So T stands for temperature. So when you guys walk up on a first thing you do is you walk in, you log into your service trade, you clock in on the job, and then you go into your point of contact, whatever it says in your description. You go in there and you check into the job, make those notes on your ticket, and then the first thing you're going to do is go to the space which is being controlled the temperature. So if you're dealing with an HVAC unit, where's my temperature being controlled at? Right here in this space, right? If the AC is in this space and the thermostat's on the wall, the first thing I'm going to do is check the thermostat, okay? It's the first place I'm gonna go to make my service call. Even if I walk in and it's blazing hot, I at least want to take a data point of how hot it is. Because that's gonna start to tell me things, how long it's been down, what's the conditions, is it running heat instead of cooling? You know, if it's only a little warm or uncomfortable, that's one call. If it's 80 degrees and it's calling for 72, that's a different call. So your mind's logging all of this information. The other thing too with temperature is what is our best methods of testing temperature? Our hands, okay? Use them. So touch lines, touch the top of the compressor head, touch the oil pump. So touch the copper line. So they tell you things. Your mind, again, subconsciously logs that information to the point where, you know, I know guys after, you know, 5-10 years can walk up on a cooler and know how the suction line is supposed to feel. They call it beer can cold, right? So, or they'll walk up on a discharge and they can feel the heat coming off a compressor. I can literally walk up on a rack and sensing the heat coming off of that rack, I can tell you if it's overheating or not before I ever touch it. Just because I can feel the heat radiating off the rack, I can tell you if it's overheating. So, and that's just my body that over time has logged that information of what's a good running system and what is not. Something's making my spidey senses go off. Okay, so temperature. So what else? If we're on an ice machine, what temperature should we be checking? Water temp, right? Ambient temp. So that's two things that we have to take data off of to know how much production we're going to do on an ice machine. So ambient temp is the space around wherever the condenser's at. Okay, we're still taking temp checks. So you're checking temperature of the water, the media that we're trying to cool. Product temp, right? You grab a can of, or a bottle of product and tell you if it's been warm for too long or not, right? Or if you open up a freezer and the ice cream's ripping off the shelves like soup, then you know it's probably got a product. You got a temperature issue, okay? It's as basic as that, but like I said, you're logging all of this information. So in the case of thermometers working or reading correctly. So now we're gonna go to the temperature control. What do I need to troubleshoot temperature control? If I'm dealing with, most of them are electronic, right? Or electric. So if I'm dealing with an A19, a BBC or an ABC 24C. So that's a remote bulb or a coil bulb thermostat, right? How do I troubleshoot that? I troubleshoot that with my meter, correct? What settings can I use on my meter to troubleshoot that? You can ohm it. So when you're ohming it out, you need to disconnect the wires from the terminals so that you're not picking up something downstream. So, but the easiest way to do that is with it powered up, checking across the switch with your volts. It's open. If you're sensing voltage there when you're going across the terminals, the switch is open. If you're testing there at this terminals and you know you're testing the same line of power, you'll get 0 on your meter. That's closed. The way you verify that is take your other black lead, ground it out, and you can see if you have potential voltage there. Okay. So when you're testing temperature, that's how you're going to go through it. That doesn't matter if it's a A12701 cold control, an A19, an electronic, and ETC. These are kind of the different styles, electronic, and then you can get into when you're testing on your controls, like your Dixel controllers or your Johnson controls. So you can test across those terminals on the back side that are making that contact for the temperature. It's all the same thing. It's all a switch. Okay, it's energizing a solenoid downstream. Okay, where would I check if I'm testing on a thermostat, an HVAC thermostat?
The common, the cool, or heat,
The R to Y.
If it's cool,
Yeah.
right? For fan,
So if I'm calling for heat, it's R2W. Okay. So if I wanted to see if my blower motor is calling, it's R2G. Yep. Okay.
Yeah.
So remember, we're on temperature. So we're right there at the thermostat. We haven't moved into any of the evaporator sections. We're just there checking to make sure, why is it too warm? Why is it too cold? Why is it not making? So on ice machines, so we can check the sump temperature. So I was going to show you guys this still to this day is my favorite temperature meter. So it doesn't sit in my man purse because it doesn't fit, but a Fluke 52. Everybody should have one of these. You can log temperatures. If you're a PM tech and you're not using this, you are wasting your time. So the biggest thing is like when you can log this and you can put it on a min-max setting. You can drop your K-type thermometers into the box and walk away. And it'll log it, it'll time it, and then you can go do other work while it's logging that time. And you come back and see what your average is, your cut in, cut out is, and then move on to the next case. In the next case, you can be doing multiple things at one time. So this is how we verify the temp check. What I do carry in my troubleshooting bag is a needle thermometer. So it's not as accurate as a K, but it gets me in the range. So, and like I said, when I'm going in, walking in and I'm just trying to diagnose what's going on to get a general idea in which direction I need to start pointing at my repairs, then that's what I use it for. It's just to give me kind of a general baseline. Again, we talked about this. How do the copper lines feel? What does the suction line feel like? So how should it feel the difference between an HVAC unit to an ice machine, right? Feeling a suction line in an ice machine can tell you if I'm in harvest, if my hot gas is open, or if I'm actually in a free cycle. So just feeling those lines, right? You got the cover off, you grab the lines. So how do the return bends? Let's talk about this. You're sitting on a self-contained unit, you got the condensing unit, right? And it's a fractional charge unit. This is one of the best ways I used to charge, right? Because I can't tell you how many times supermarket guys go out and they work on a small fractional charge self-contained and they hook up their 6-foot hoses to the self-contained unit that holds 3 ounces of gas, right? How accurate are they going to really get that charge?
You're really,
Right.
it's ruined.
So
It's ruined.
yeah, you either pull too much out or you're trying to guess. So now you got to get that cap tube system within a certain amount of temperature. So what I would do is try to get it into the range and then I'd go off the return bends. So that's how I knew. So those return bends, 2/3 warm, 1/3 condensed. Starting to subcool tells me that I'm good. My charge is good. I'm subcooling across that condenser as long as that condenser is clean. 2/3, the rule of 2/3, 1/3. And that's filling down the return bends of that condensing unit. So on that condenser coil, I just run my fingers down those return bends. It's warm, it's warm, it's warm. It's room temperature, a little bit warmer than room temperature. That's when it's condensed into a liquid. Okay.
What are you talking about, right?
The bearings on the.
Yeah.
Yeah, those copper return bands where the refrigerator's going back and forth. So again, guys, use your hands when it's running good. So once you make your repairs and everything, test it again. Your brain's extremely intelligent. It logs that information. I promise you, I can tell you from experiences, like when I walk up on a system and I grab an AC outside, when I'm working on a split for my neighbor, or if I'm out on a RTU unit and I'm grabbing lines, I can tell you if circuit 1's running and circuit 2's, doesn't have enough gas, just because I felt it for so long that I'm like, that one feels good. That one's a little warm for the conditions. So I got something else going on. I got a restricted metering device. I got valves in my compressors that are bad. Something else is going on. I've got something on low charge. That comes from feeling it when it's right, knowing that a train unit feels this way, knowing that a carrier unit feels this way, knowing that just depending on the year of the model, whether it's a Weathermaker or a newer series, that's what we do. And you do log that information. You guys ever worked on a piece of equipment, address the symptom that you thought was a problem, and you're driving away and you don't feel good about it? You're like, dude, I'm going to be back there tomorrow, and I don't know why, but I'm going to be back there tomorrow. That's your subconscious. That's something that did not compute from the last time that you made the repair and you didn't get called back. Okay, so when you're driving away and your spidey senses are going off, probably good to turn around and go back and do a secondary check and follow the method, right? So let's say we go to the thermostat and we're like, oh, the slider bar on the A19 was set to 12 differential instead of minimum, the 3-degree differential. Okay, so I'm just going to slide that back up, takes off, turn. Are we done? No, we're going to keep going. We're going to finish out the service call. We got called out for the hour charge. Okay, guys, if you go out and you flip a switch or clean a dirty coil, they're paying you for the hour. Run a diagnostics check on the thing. Make sure that everything's good. That's potential work. It probably, if it's overheating especially, you may have caused internal damage to that compressor. So you may have other issues. If you've broken down the oil, you may be plugging up some kind of valve. Okay, if you've got breakdown going on now inside of that system. So a couple different temperature controls that we work off of. You got your regular A19 or any of these type of thermostats. You got your pressure controls. I don't see it a ton anymore, but they used to use low pressure control to cut in and cut out a system. So very rarely do they use that anymore. So you got your EPR. So where are we going to find that at? Yep. Yep. On a parallel system. Why do we find EPRs on parallels mostly? What do you need on the back side of that EPR in order for it to regulate? Back pressure, right? You got to have that constant pull, that constant, it can't go static. And so in order for an EPR to function, you need a pressure differential across that valve. So you need a suction group pulling on the back side of that evaporator pressure regulator. Solid state thermostat controls. What are we talking about here? Those dick cells, right? PCBs. So printed control boards. So a lot of those solid state thermostatic controls. So some of them, if they're not using like a C-type relay and they're using resistors, that's a solid state. Okay. So they'll run it through a series of time delays in order for it to manage a delay on make or delay on break. You guys ever use those old delay on make or delay on break timers, delay timers? So they're just using resistors in there. When you flip those ditch switches, it puts resistors in play until the potential voltage gets there. It's not going to kick on the relay. That's all you're doing. So those are solid state controls. Make sense? Okay. EMS controller. So we have a few of these. Ty lives in this world, so this is a way. So where would we check our temperatures on EMS controllers? What's sense and temperature?
Temperature sensors.
And what are those? Not you, Ty. They're 10K thermistors, right? What is a 10K thermistor? If you opened up that metal sleeve, what would you find down inside of that metal sleeve? Just a little resistor, right? 2 wires soldered on the end and they're slid down in that sleeve and then they're siliconed in there, right? And what that happens is that resistor changes resistance depending on the temperature that it's sitting in. So when that resistance goes back and tells that controller, hey, it's time to turn on or it's time to turn off. It tells the logic in that controller. That's all it is. It's as simple as it is. That's why that thermistor is only $12 to $16. Okay, so it doesn't matter what color the leads are. All the leads tell us is if it has high temp silicone or low temp silicone or what the application is for it. It's still a 10K thermistor, right? So, but there's 14K thermistors, there's different resistance of thermistors, so you need to make sure you know what ohm resistance you're dealing with. Because if you take a 10K thermistor and you hook up a 14K thermistor, it's going to give you a different value. How do you guys?
That's the hard part, is out in the field, is finding out what the resistance is of a particular piece of.
So how do we do that? That was my next question. How do you guys
That's where I run into problems.
How do you guys test resistance on a thermistor?
Put it in ice water and
Put it in an ice bath.
see if it's.
That's the best way to do it. Ice bath is going to give you probably the most consistent field, conditions. So you just fill it up with mostly ice, a little bit of water to where you can stick it in the
It
water.
should zero out, right? If it's.
No, it's going to give you a resistance value. So what you're going to do is find out what that resistance value is for that 10K. I can't remember off the top of my head. Yeah.
That's where I run into problems.
If you guys need
I
a
don't know where
chart,
to
get a
find
hold of me, get a hold of Ty, get a hold of Leo, so
it.
we can help you.
A lot of checking resistance and all the time, a lot of.
Just
you know, like-
when you're checking them, make sure you understand which ohm resistor you're dealing with. So, because when you're dealing with any kind of logic controls, because even on the Dixel controls or they're gonna use the same resistors. And the thing about it is, it's the funny thing about Dixel and stuff is that sometimes it has to be their thermistor and not CPC's thermistor, and sometimes it's got to be microthermals because there's a minute adjustment in there. So we need to understand which brand we're dealing with, because certain controllers, like when you go in and you set the controllers, you have to set it up for that sensor. So don't mix and match them. Just because you have a 10K on the truck doesn't mean you can swap it out. So there's a lot of the controllers, you can actually go in and tell it that it's that thermistor, and now you can use it. But you actually have to go into the programming and tell it. So a sensor is not a sensor is not a sensor. A thermistor is not a thermistor is not a thermistor. So you need to make sure you're using the OEM as much as possible. So I will tell you this, is in a jam, I can throw a different one on there and go in and program the values in there, but that's something that you'll have to get on with a programmer, and they'll help walk you through it. So the best way to do is just put it in an ice bath, check your ohm resistance, okay? And you can usually get online and type in microthermal 10K thermistor values, and it'll send you a PDF chart. That's what I've done in the field with Google. So we talked about these. It's all over the place now. This is kind of an old slide, but what we used to see mostly is the A19s. So we still see a ton of them out there. So the A19s is a little gray one, the Johnson control. It's got a little slider bar on the side. So it's got the 3 lugs. So closes on rise or opens on rise. So, and just depending on what your application is, you can use an A19 for a few hundred different applications. So the difference is understanding when you need a remote bulb or a coil bulb. So a BBC or an A19, ABC 24C is the most common thermostats we use. Everybody should have them on their trucks. So if you don't, make sure you have one on your truck, because we use them all the time. So the other thing too is cold controls. What you need to understand about cold controls is it usually always has a constant cut in or cut out. One side of that switch is always going to be constant. The adjustment comes on the other side of that switch. So you need to make sure you read your instructions and understand the application of which you need your cold control. Okay? Because one side of it's always going to be like 27 degrees cut out or 34 degrees cut in, and then the adjustments coming from you adjusting that knob. Okay? So just understand, A12701 is a really common one, and it's because they were in True cases for years. I don't know what they're using now, but True, Continental, all those self-contained used the A12701. They've kind of got away from that. Now they use heated resistors and all kinds of different fancy stuff. So common characteristics of a mechanical thermostat. So you got your pressurized capillary tube. This is the mechanical. So there's pressure in this. So, and then 2 or 3 electrical. So this is a single pole, single throw. So depending on the terminals on the back, so like an A19 would be a single pole double throw. So you can either throw one way or the other on the switch. Okay. A differential or a range in the thermostat between CI and CO settings. We just talked about this. Cut in and cut out. So when you guys are dealing with wiring diagrams or you're dealing with any kind of instructions, CI is cut in, CO is cut out. Hopefully that's common knowledge. There's your A19 remote bulb. What I will tell you guys about this is what I hate about remote bulbs. When guys string them across and they don't secure the cap tube. So use what you need and then secure the cap tube.
I like when they string them up and put them right next to a light bulb.
Yeah. Or they try to wrap the cap tube around something fancy, or they undo a screw a little bit. I've seen them where they undo a screw and wrap it around the screw to make it, and I'm like, just you know, leave whatever loop you don't need, secure it with a zip tie, cut the zip tie off, and then use a little clamp in there. And if it doesn't feel like it's secure because it's only one, use a couple of those screw hole zip ties and use 2. Just make sure that you're not using the super fat ones and cover them, because you're using the space in this bulb to sense the temperature. So, and then the gas is going to expand or contract within that bulb, push pressure down that cap tube. That's why it's so small, and push on a diaphragm inside there and open or shut those set of contacts. And that's how it works.
Where does it sit?
Wherever you want it, wherever you want it. Most of the time, they're going to set it in the return air of the evaporator. So where it's drawn through.
Like on a cooler.
So if you're looking at a low boy, you'll see them right here in between the fans. It'll usually be strapped to the fan guard. If you're looking at a traditional, it's going to be on the back side of the coil. So usually we like to hide those with a remote bulb. Just put a remote bulb on the back side because it's drawn through the back anyway. So I like the remote bulbs on the back side. They look cleaner, they work better, and they're out of the customer's line of sight. Because I can't. Do not in installation put the knob on.
Oh, yeah.
That becomes a toy for everybody else. It comes with a black knob. Do not put the knob on. So anybody that should be touching that should have a screwdriver on them. Yeah. So set it and forget it. What you guys will notice on the inside of this thermostat is there's a slider bar, okay? It's your differential for your cut in and cut out. Keep it up minimum on walk-ins. So it's set to 3 degrees. We don't need more swing than that. I've always just set it to minimum. I can't tell you how many times I've gotten called out, and for some reason somebody's messed with the slider bar, and it's out at like 8 degrees or, you know, at maximum, and I'm like, what good does that do? So we push those up to 3 degrees. It's just, you got to take the cover off. You'll have your 3 screws here for your terminal landings, and then you'll have a little metal slider bar right here on the side. Just push that up to minimum. MIN. 3 degree differential should be fine. So, I'm going to talk to you about when you guys are buying parts. This is for any part, not just the thermostats. Well, you guys need to make sure you understand if it's opening or closing on rise or fall. So I can't tell you how many times a guy has been handed a pressure control or handed a thermostat, goes out there and spends 2 hours and can't get the thing no matter how he adjusts it to work right. It's because they gave him the wrong one. It's either opening or closing on the wrong set point, or it's switching opposite of what they want, okay? So make sure you understand what closes on rise or opens on rise is. Make sure you're getting the right controller for the application. So happened to be twice. So, this is your coil bulb stat. This is the one where you'll see on the back side. Obviously there's no mounting here. I like this because people don't get creative on where they mount the bulb. It's just it's right there. It senses right here. This is your cap tube. So, and it's going to sense your temperature there, and it's going to open and shut the diaphragm locally. Okay, it doesn't require that remote bulb.
Probably one of my favorite temperatures.
This one's just nice. It's just, you put it there, you know, somebody's not going to snap the cap tube or get crazy with it. So again, this is a mechanical cold control. Like I showed you here. Coil controls are preset for a specific range and differential. We talked about that. We see these guys. So when you guys get a pigtail instead of just a straight cap tube, what is a pigtail? And they make pigtail tools, right? Does everybody have a pigtail tool? I suggest getting one. So what does it tell me when I have a pigtail end?
You're gonna shove that down a freaking tube
Right.
and the evaporator. You're gonna get it right in the middle roughly. Or something.
Yeah, usually a pigtail is air over or area sensing. So it's ambient sensing. So it's not direct contact. Okay. You're going to put it away from the point. It's going to sense the air going across. It's not a direct contact stat. Usually when you have a cap tube like that, you're going to shove it down the well and you don't care if it touches the sides of the copper, right? That's direct contact. So you need to understand if you're going to put this in an airstream and it comes like this with this straight end. So, I mean, I used to take my control screwdriver and pigtail around my control screwdriver, loosen it up and then slide it off my control screwdriver and it got the job done. Now they make a pigtail tool. I didn't have it at the time. So, but they're nice. And you can take this stat, pigtail it, and then you can mount it in the airstream. Okay. In the return airstream is where you're going to put that. So, aero thermostat is recognized by the pigtail at the end of the cap tube. This is the style of thermostat that will be set for setting the low setting and then the differential. So you're going to set the low event and then the differential. Okay. And we see a lot of this style of controller in what? The low boys at Maverick, right?
Yeah.
In the freezer. And they're never set right. I adjust them all the time. Where are these supposed to be set in a Maverick? This is for defrost termination, okay? So it's still temperature. We're still talking about temperature. To defrost termination is a temperature setting. Where should we be setting those? On the freezer. Where are these mounted? Yeah, there's a hole in the evaporator and they slide right down the middle of the evaporator, okay? So, and they're pigtailed like this. So where should they be set at? 55 degrees.
55 for
Yep.
cutoff, right?
Yep, I've seen them as low as 30. So, and I've seen them as high as 70. So,
Okay,
or I've seen them pinned all the way as hot as they'll go. So set that thing at 55, should be good. So remember, you're not testing product temp, you're testing the coil temp once the ice is off, right? So if that coil and the heaters, the electric heat strips are right by there. So as long as there's ice there, it's not going to shut down. But as soon as that ice is gone and those heaters are heating up that coil, that control component is going to take those heaters out before we get too warm. So how do you know if it's set wrong? Water droplets on the ceiling, right? That could be one of the biggest reasons, right? So if you guys are out doing PMs and you see the water droplets on the ceilings of the box, this could be one of your biggest components of that problem. Infiltration is going to be a big problem. So you need to check the door sills and you need to check the penetration sills and you need to check that. But the other thing is the defrost is getting too long. Those panels are getting too warm, they're condensating, and then they're refreezing and you get droplets and droplets and droplets. So it means you're warming up the box too warm in defrost. That's that adjustment, okay? So if you guys are walking in, don't just say, oh, they all do this. That's I hear that all the time. I'll walk out on a PM guy and I'm like, you got a problem with your defrost. No, they all do that. No, they're not supposed to do that. So let's get it fixed, okay? So low pressure controls, used to see these on a lot of self-contains. So the problem with low pressure controls is there's a lot of existing conditions that can mess with this. So in the cut in and cut out. So, and also it creates a broader range for cut in and cut out. You can't run them as tight in temperature. So they're not really effective as like they used to be. So
Those new freezers with the 448A,
yeah.
they are real sensitive when you're setting them up.
Oh yeah.
They're real sensitive.
Well, it's because you're dealing with a blend.
Yeah,
So, and you have a
exactly.
glide.
Yeah.
So anytime
Yeah,
you're doing,
pay attention to that. It's the first thing I check when I go to a freezer, is what that settings are and if it's doing its job.
yep. Yeah, for the new blended refrigerants are going to give us a lot of new problems and new challenges that we're going to have to work through. So especially 448, there's I think 6 components in that refrigerant right now. So yeah, so EPRs or EEPRs, okay? So this is another temperature setting, right? If we go to the coil or we go to EMS system and we're looking and their temperatures are off, what are we first going to do? Do we adjust this first? What do we first do?
What was the question?
Do we go after this very first if the coil is warm? How many guys go after this very first?
I think that's more of a, like a bypass type of thing.
Should we do this whole process first before touching this?
Probably.
Why?
It's a bad habit, man.
Do I need to know if the condenser's
That's not
clean
tech savvy.
or the evaporator's clean? Sorry. Before I mess with the temperature setting? Do I need to make sure that my fan blades are clean? Do I need to make sure on heat loads, okay? Do I need to make sure my metering device, where my superheat is at, once I know that the coil is clean? Right, and then,
Come
and
on,
only
man. We
then,
got 30 minutes, we got 2 minutes.
and, yeah, right? If I get a charge an hour, woo! So that's, don't touch these unless you know you've gone through your full diagnostics. Meaning you check your evaporator, you know it's clean, you know there's no restrictions in there, you check the frost pattern or the sweat pattern, okay? That's all gonna come into E, we're gonna talk about that. So, and then you've gone after and you've taken your calibration tools, not your charging hoses, but your calibration tools. So your clamp, you guys are old school and you can still use the clamp instead of gauges, good for you. So if you're not, and you only know how to, and you only know how to do it off what your Bluetooth tells you.
No.
So for superheat, I don't care either way, it gets the job done. So if you ever want to know the old school way to do it, give one of us old guys a call and we'll help you out. So that's when you check, that's when you'll make that adjustment. So I can't tell you how many times the guy was there for 20 minutes. He's like, oh, I turned the case down. What would the Airstream look like? Because it's an open face case, right? It was the honeycomb clean? Was the case clean? Was the fans running? How many of you guys know we deal with adjustable speed motors now in the cases? So we have those. So I can't tell you how many times this guy goes after that and turns the speed up because the case is too warm. I'm like, but it was working yesterday. Or it was working last month. Like, why was it working last month at that speed and now this month it needs to be turned up? Remember, let's get to the bottom of the problem. So if the motor was working a month ago, something else is changing. It wasn't the motor. So if it's running. Difference between the EPRs here. This one's a suction stop for defrost. So if you're dealing with an ORIT, no suction stop. If you're dealing with a SORIT, so you're dealing with the suction stop. It's got the solenoid on it. Okay. So that means it's shutting down. It's shutting that circuit down at any given time for any given reason, stopping the flow of refrigerant. It's usually for defrost. So they'll shut that circuit off. So build back pressure on the coil. It'll shut down the expansion valve and then it'll defrost, right? If you want to leave refrigerant in it, if you want to pump it down, and if it's a shorter system, you'll shut down the liquid line solenoid, pump the system out, compressor will shut off if it's a single remote system. So the reason why it's easier just to shut it off is because if you shut it off on a big rack system, you don't have to pump out 80 feet of line, right? So you just shut it off, the back pressure in the coil builds up, it shuts the expansion valve down from the back pressure, so it stops refrigerant flow to the coil, okay? Solid state temp controls, like we talked about, this is what we're dealing with for the most part on the new feature cases, all the new self-contains coming out, any of the R290 stuff is all this. Nice thing about this is you can network this into a larger control system a lot of the times. So that's what's nice about these controls. A lot of these controls have like a 485 or an echelon connection where we can actually grab onto this and see what the case is doing from the main controller. EMS building controllers. The old E2, still just as reliable as it ever's been. So
It's a great one.
it is. So EMS controllers are used by big box stores and small format now. Thank you. So they control systems and maximize energy efficiency. They do a lot more than that, but that's the general reason why EMS control came out, is it was really to just start thinking of the system holistically, so that you were reacting off of global temperatures and humidity and the case. So that's the biggest reason for the energy efficiency, is now you got the whole system thinking together and learning together and working together, instead of this case working over here and this case working over here. So as standalones, now you've got the whole rack bringing in all of that information and then adjusting the rack pressure and stuff based on all of the data it's getting in there, and it's learning off of the algorithms that are placed inside of the controller. So defrost timers. So they all have about the same terminals. Doesn't matter if you're using the Groslin or Paragon. So if you're using a mechanical or electronic timer, so it's all the same. So you got your 1 and 2 is your power, usually your N is your other side of your power. So, and then you got your 3 is, screw this up, 3 is your defrost, 4 is your solenoid. So, and then X is, or the blank one, is your termination. So it sends power up there, energizes the solenoid, drops the clock out of defrost, and carries on. So,
Which is a common one people just.
Yeah.
does anybody here still bypass click-ons?
I used to.
If you have one of those guys in your crew, point them out. Do not bypass a defrost termination click-on. Okay. Do not take out a drip time. Do not. You're gonna ice up a coil, or I mean ice up a drain.
We used to do that just to get us by for like whatever the weekend or the day. But
It'll get you by for a day. I'm not.
Gotta go
Yeah.
back and get that fixed.
But I can't tell you. So the longest, Rusty Walker said, the longest repair that'll ever take place is the one that's temporary, right? So you go in there and you throw in a temporary repair with the full intentions to go back. You clip the process tune on a headmaster or something. You're like, I'm going to come back for that. I'm going to order the headmaster and come back. It's middle of July. What does it matter in August, September, and October comes around? So, and now you're still just running everything through the condenser, and you're stacking gas up at the unit, and it's not getting out of the case. You don't have that differential across your expansion valve, and you're like, what the hell's going on? And then you find out somebody in July clipped that tube on a Friday night at 2 in the morning when it's cold. Now you're freezing on the roof, and you got to change that headmaster out. You're pissed. Yeah, that's never happened to me.
Sounds a little too specific.
Yeah. So
When you replace the Groslin, like you were replacing an 8140 or something like that, you've got to put a jumper between 1 and 2 on this for the operate correctly. You got to supply power to both 1 and 2 so that you can do a defrost.
yeah, because there's 2 switches in there. That's why. 1 and 2, one goes to the F terminal, and the other one goes to the 3 and 4 terminal, switches back and forth. So if you want to run F independently, your fans on the Groslin, that's why 1 has one switch that goes over to F, and the 2 has the other switch that goes over to 3 and 4. So if you don't have that jumper in place, then you're going to lose power to one of the terminals. That's why you need to make sure that jumper's in place. Okay. The other thing too is like the biggest, highest piece of crap fail point on this thing is that face. It's made of plastic cogs. It gets a little bit of dust in it. It doesn't rotate, locks up.
I was just gonna say.
I carry the faces.
Yeah.
Yeah,
Because
just
very,
the
very
voltage.
few times is that board. It's a 40
Make sure
amp
it's the right
seat.
voltage on
Yeah,
it.
Yeah, well, if you pull the face off on the back side of the face, it says what the voltage is for the actual clock.
There's
No,
another
don't
one
always
saying-
trust that either, because somebody come in there and put the wrong one in there to begin with, so you gotta find out.
Well, you can, yeah, you always use your meter.
Yeah, you gotta know.
There's these things you guys should have on your tools called the multimeter. So-
It could be a 240.
Well, how many, the reason why I say this is how many times you see a technician, well, I haven't seen one, but I've experienced firsthand where you go up and you go to turn that clock and it's done. It's not gonna move. So you don't even think twice. You just automatically think, oh, replace it. So you just replace it with another face clock and find out it's the wrong voltage. Luckily, I have never fired one up on that, but I have walked up on somewhere. I thought I had the right clock. I go to put it in, it's not the right voltage.
Okay.
Cause those switch from 120 to 240. the Groslin.
Yeah, if you have a DTMV, yeah, it'll switch.
I'm not gonna lie, there was a clock before this one that I really liked that had the copper arrow piece that you push in and then move it to where you want.
Yeah, it's a Paragon.
The Paragons, in my book, I think were
Yeah, they're more reliable.
The best ones.
They are.
They're more reliable.
Reliable.
Anytime you see a manufacturer mass producing a different type of clock, it's because it was cheaper. So make sure you understand the style and brand. Again, it doesn't matter if you're dealing with an 8145 or an 8040 or a different, the terminals are all the same numbers. It's just the variation of where they land on the clock. So you just need to make sure some of them have different marked terminals. So if you look at your diagrams, just make sure if you're going from like a Groslin and you don't have an 8145/20 on there, but you have an 8040, just look at it. You can still make that one work. You just need to look at where the terminal locations are. So, and the 20 is 208 and the 00 is 120. Okay, just so you know on Paragon. So, no matter what the equipment, always go to the temperature first, or the area of the temperature, right? So go to the area of the space that you're trying to control the temperature in. So if it's a case, you're gonna go to the case. If it's a HVAC unit, you're gonna go to the space in which it's controlling. You got an ice machine, you're gonna go to the ice machine. So if you're doing ice cream or something, what temp should I be checking on the ice cream? The ice cream temp, right? That's where you shove a needle in there. What's the temperature of soft serve ice cream? Anybody know? 19 degrees. So if you ever want to check if you're drawing a cone and you want to know if your soft serve is a good, soft serve ice cream, you draw that cone, you shove your needle thermometer in there. If it stands up on its own, you can tip it upside down and it's an opaque, it's not runny, and it's 19 degrees, you got good ice cream. Call it a day, go home. So for all you guys that want to work on soft serve. So evaporator, when checking the evaporator, we should be checking a few items.
Y'all be solved.
Let's talk about it. Frost and sweat patterns. What should they look like?
Just a nice thin frost.
Should they be like heavy at the front of the coil and then like dry at the back of the coil?
No,
You
it
should
needs to be
still
a
be able
even
to
frost
see in
pattern
between
across
the
the
oil fins.
So when we're checking, and we'll talk about this in H and C and H2, but when you're checking superheat, what are we checking there? And why is it important to be, so what on the low, on the low profile beer cave and freezer condenser or evaporators we're seeing in Mavericks, where should that superheat be?
On the freezer,
Or a cooler?
or 6 to 8 on the freezer.
4.
10 to 12.
4.
4 to 6.
Heat craft on the low profile wants a 4 degree. They're flooding that coil. So, okay, because you got the two coils and you got the split distributor, right? They want a 4 degree superheat. Now, if you set it to 4 and you go upstairs and you're coming back at 16 on your compressor, then back it off, okay? Evaporator superheat is telling us the efficiency of the heat transfer at the evaporator. So they're having you set that to 4 to make sure that there's enough heat absorption happening across those low profile coils, okay?
Are you teaching them the bottom of the swing, the average of the swing, instead of superheat?
It's usually the average of the swing, so I don't want, you can go bottom, but you're gonna be flirting with it up at the compressor.
So I just Walmart straight to go from the bottom swing.
Oh, do you? Okay.
I know I do the average.
Yeah, I've always done the average, but if we have a certain that's teaching the bottom, then we'll go for the bottom. At Walmart? Yeah, well, when you're dealing with a rack, you can actually pull an 18 degree superheat of the compressor and you won't take out the oil. So you can get away with it. So the reason why I want to do average on self-contained units is because a lot of times there's not an accumulator in play. There's no fudge factors for that liquid to come back a little bit too hard to the compressor, and then you're taking out compressors. So the finite adjustment of doing any kind of superheat is you want to make sure that you're adjusting it to manufacturer spec, but then where do you want to verify that if you're too strong, if you're coming in too strong at the compressor, right? You need enough heat transfer happening at the coil that you're allowing enough refrigerant to get in there to boil off inside the evaporator coil. But what you don't want to do is bring too much into where you're bringing back liquid to the compressor, okay? So we'll talk about superheats, but again, do not make any finite adjustments. The reason why this is at the very end of the process is because we want to make sure we check all of this stuff and that it's clean and that the motors are working and that it's functioning properly. And then we go after our finite adjustments, okay? We don't touch the finite adjustments and the heat load checks until we go through the basics. Make sure that everything's clean, fan motors are running, heaters are working, it's not iced up. So because we can't make adjustments if any of those conditions are in play. Because now you've just made the system, you just hurt the system and you've done the opposite of what the customer called you out for. Okay? So we just want to look at the frost pattern. We don't want to do anything about it right now. We just want to acknowledge that there is a frost or sweat pattern and what it looks like. Okay, and we're going to make notes. On the temperature thing, we're going to check everything and we're going to make notes. Okay, we're going to say, yeah, I need to look into that, but that could be being caused by that. So you're looking at the system holistically. This is how you do a diagnostic rundown. So is the THV metering device feeding correctly? So your frost pattern will tell you that. Your ears will tell you that. Okay. Yeah, if you hear that thing starving out. So is that an expansion valve problem though?
It could be low on gas.
Just because the expansion valve sounds like it's freaking wide open and it's starving, could be out of gas, it could have a couple of different extenuating circumstances. So we're not gonna do anything with that expansion valve yet, right? We're just taking notes. How does the suction line feel leaving the evaporator? Okay, so if you can hear the expansion valve wide open and you feel the suction line, okay, and it's really, really cold, could something be stuck in it? But if you feel the suction line and you hear the expansion valve and it's warm, probably out of gas, right? Remember, I'm getting multiple points of reference for my brain to compute what's going on with the situation. So how does the liquid line entering the evaporator feel? Why does that matter?
Because if it hasn't removed the heat, it's going back hot, it's not gonna pick up heat.
It's gonna affect my enthalpy, right? I only have so much thermodynamic pickup that happens depending on the temperature of my gas. Why do we mechanically subcool liquid in the supermarket trade to 55 to 65 degrees on average? Now I know that some markets run that colder, but why do we do that? Case manufacturer and a rack manufacturer, right? Okay, case manufacturer says I need this liquid temperature at this for this case to run at maximum operating performance. Okay, so and it's in that range. So anytime that's out of range, the case manufacturer says, not my problem, talk to your systems guy, right? So you have to control that situation. So if we're working on an HVAC unit, does subcooling matter? Do we test superheat on an HVAC unit?
Yeah.
Do you?
So I do subcooling.
I do subcooling, because if you call an HVAC manufacturer, are they gonna ask you about superheat? They're gonna ask you about subcooling. 9 times out of 10, they're gonna ask you, what's my subcooling? And what are they shooting for? 10 to 12, right? That tells you the charge is good, the condenser's clean, that it's actually subcooling the liquid, and then it's going to hit their expansion valve at their temperature that they know that expansion valve should feed if it's working properly. That's the first thing they're going to ask you is my liquid, do I have enough charge? The subcooling will tell me that. And am I condensing? The subcooling will tell me that. Because their biggest faults is the condenser gets plugged or that it's low on charge. So subcooling will tell them that. So, and then how is the airflow? Have we touched the expansion valve? The expansion valve might be acting up, right? What's gonna the airflow have to do with? What components do we need to check airflow? I'm on an open face case like the Hill Phoenix cases that we've been putting in at Maverick.
Honeycombs, evap coils.
Honeycombs,
fans.
VAP coils, fan motors. What else? Return air grill. So you're gonna check that whole stream, okay? And you guys been standing in front of a case and feeling it rolling out all over you, blowing in your face? Usually what customers overstock past the load line, and it's just throwing that air off and then they call you and they say it's too warm, the thing's broken, it doesn't work right. Okay.
And you guys are really selling these today, aren't you? Yeah, just stack them outside the freaking.
Okay, again, I just want you guys to use your senses. Your senses are going to make you the difference between a good, better, and a best technician. They'll start to turn you into what I call a craftsman. I know maybe 5 craftsmen I've ever met in my life, but they're the guys that love the business and they can tell me everything about it out of their head. They've been doing it a long time and they do all this stuff. And every time I talk to them, I say, what do you guys do? What did you do when you troubleshoot? Because they amaze me, and they always tell me, it's just about remembering, using your senses. It's experience. It's time in the field. So if you guys are going out on calls and you're just going to the symptom and you're addressing the symptoms, you just missed an opportunity to learn something. And I can't tell you how many times that guy comes into my office and says, dude, I'm doing all this stuff and I don't know what I'm doing. Well, I was trained the same way that you guys were. I was thrown out into the field and said, hope it works out, right?
Good luck.
But I actually went with a couple managers and I watched what they did. They took a little bag like that in with just a couple tools, and they were smelling. When you walk into a walk-in, you can smell the food. You know it's been warm, right? Cooler freezer. So you know that the warmer the temperature gets, the more that food starts to spoil. When it starts to spoil, it puts off an odor. You can actually smell it. So when I walk into a freezer and I can smell the product in the freezer, I'm like, oh crap. this has either gotten really warm or it's warm now, right? Before my face and my hands, then the sensible heat hits my body and says, yeah, it's warm. I can smell it as I open the door. I can hear the expansion valve starting. I can hear the fans paddling water. I can hear the case laboring for some reason. I can hear the compressors barreling down. I can hear, you know, I can tell you what a good sounding stroll or a good sounding reciprocating compressor sounds like, and I can tell you one under stress. So, you ever done that when you start them up and you start to open the valves and you stand there and you listen to it take its load? So, yeah, you're learning something. So, that's what I'm saying is your guys' senses are your best tools. They really are. And it will make you a better, your brain is your best tool and it's taking in all this data. So, and as you guys troubleshoot, make sure that you take the opportunity when it's running to see how the lines feel, to listen to what the valve sounds like, to listen to what a good cycling compressor sounds like. And then one that's when you walk in, so the next time you walk in and you hear, hey, when I was working on a 3D discus compressor, it didn't sound like that. Something's wrong. So, okay.
They just stick the product on top as an ice block.
That's an insulator. We're no longer transferring heat.
Oh, that's my favorite on a Friday
Okay,
afternoon.
let's take a moment when we're talking about ice patterns. Can I tell what happened by the ice, the way it looks?
Oh, yeah.
So if I have what we call a hoarfrost, right, the heavy snow, what do you got? What's the condition there? What caused the ice up? No defrost, right? There's a difference between snow and ice. Okay, when you get up on a coil oil and you see solid ice and you're there de-icing it for hours, or snow. I love snow. Snow comes off the coil really easy. Yeah, it's like fantastic. I got snow. I'm not going to be here very long. I come up there and it's solid ice. I'm like, crap, I got ice. I'm going to be here a while. Okay? It tells you something. Okay? It tells you whether it's not long enough defrost, whether doesn't have a drip cycle, whether somebody took out the defrost termination. Okay?
Is this the snow one are you talking about?
No, I'm talking about ice.
Ice, okay.
Okay. So ice will cause by melting down and then rehardening, melting down and rehardening. So it turned to water at some point in time, and then it crystallized, turned to water, and then rehardened to ice. Okay? Snow is moisture in the air that hits the coil and crystallizes the snow. Hoarfrost, right? And it keeps on building. Snow until we plug the airways of the coil. So what is that? Defrost timer got stuck, never went into a defrost. Heaters aren't working. Something else, okay?
Gaskets or something too.
Could be heaters not working too if it's ice, because if it goes into an off cycle and it's right there on the cusp of being too warm and the ice does start to melt and the heaters never come on or half the heaters come on, it's going to be solid ice, okay? But hoarfrost is usually never ever defrosted for whatever reason. That's when you go to your time clock, that's when you go to something. So that's why identifying your frost patterns and identifying the type of ice you're dealing with. So this is usually what you get on an AC. It's an A coil. So it's nice and snowy. You guys wonder why it doesn't take long to get ice off of an HVAC unit? Why is that? Because every time it's not they don't defrost, they off cycle, right? And if they do off cycle, the ice eventually comes off because it's 70-degree air all day long, right? Yeah, just turn on the fan and turn off the cooling circuit. So that's why it's so easy, because it's usually always snow. So, but this is either a plugged filter, a slipping belt, something is not moving enough air past that coil, so it's causing a snow condition. Metering devices. When examining, not adjusting, not making your repairs, don't pour hot water on the bulb yet, don't pour hot water on the valve yet, like, and don't ever use a torch on our valves, okay? When examining the evaporator without gauging up, we're not gonna ever gauge up to the system until the H, okay? Ever. So, what are some ways to know if the metering device is feeding properly? Frost patterns, one. Can you hear the valve throttle and open and shut? I can. Okay, if I'm watching the valve and I know, and I put my hand on the what line, suction line, right? And I can hear that valve opening and shutting. My frost pattern looks decent. My line feels good, and I can hear that valve opening. I've just done a diagnostic check, right? Without ever pulling out a tool. So again, when it's working properly and you open up the pan and you're like, case is good, take 5 more seconds and grab the line and listen to the valve and watch what a good case it's running at 27 degrees on an open face D6 case looks like and feels like and sounds like. You'll log that information. That is going to be your best. No supervisor or experienced technician is going to teach you that. Your body has to gather that data. So you can go out with a manager for 6 weeks, and if you don't touch one line or listen to one thing or look at the system when it's working right, you're missing opportunities. Every service call you guys run, use your senses. That's the best opportunity you have for your mind to log and learn the information it needs to become a great technician. So when checking the expansion valve, how do you check the power head? What's our bodies? 98.7 degrees, right? Is there a case that's 98.7 degrees? So if I hold the bulb in my hand, am I warming that bulb up? What's in that bulb? A gas, right? It's going to start expanding. As it expands, it's going to push down on that diaphragm and push down on that push rod inside the valve. Should throttle open. Okay? If it doesn't do anything, it might be your problem. Okay? What's the next thing you can do? How do you check for non-condensables? Pour some hot water over the valve. If there's non-condensables in the system, it'll stick the valve. So if it sticks the valve, could be an oil issue too. So we'll talk about that when we get to the C. So the problem is, guys, if you have a lot of valve issues or historical issues in the store, and this store over had a valve issue, and this had a valve issue, and this had a valve issue, where's the first place I'm going to go? If I'm a rack technician, I'm going to go look at the oil. What flows with the refrigerant and why? Oil. Why does oil flow with refrigerant? To oil all of the mechanical valves in the store. If I'm having valves sticking historically all over the store, it's because the oil's broken down and I've lost my viscosity in that oil and it's no longer lubricating the valves like it needs to. So for all you guys that want to be rack technicians, good luck. That's a 2 in the morning thing that happens to me. So. How do you know when you have a plug cap tube?
Geez, this is a hard one.
It's not.
Those cap tubes are.
When I first learned about cap tubes, I learned them on a Bania and a Subway. Subways use a lot of cap tubes on their Danfrosts. You're not going to hold temp.
Without gauging up, how am I going to know that I got a bad cap tube?
If you got heat in your filter,
Compressors frozen out, starting.
What's my return bends going to feel like if I'm not transferring any heat? What's my compressor going to feel like if I'm not giving it any cooling? Right? So going through the cap tube, I'm gonna meter how much refrigerant goes through it. I still got to maintain a certain amount of superheat for that compressor. So if I'm restricted, what can I touch?
Compressor.
Top of the head of the compressor, right? It's gonna be pretty hot because I'm not getting any cooling going to that compressor. What's the next check I'm gonna do with my hands? I'm gonna go down the return bends of the condenser. No, there's not gonna be any heat transfer going on because it's gonna be hot. Okay? Because it's going to be stacking behind that restriction. So, okay, makes sense?
Mm-hmm.
So,
But say you don't have, like, in a cut table, like yesterday I ran into this. Like I've changed the filter dryer and it just happened to be the filter dryer, but there was doubts in my mind that because it was 134A and we know when that 134A gets hot, that compressor, it comes up inside the cap tube. You got a rail, you don't have a condenser to fill down the coils.
right.
And you can't physically get up in there.
My first test is going to be that compressor. So, because cool gas keeps compressors alive. So, and good voltage. So, if you're restricting, that compressor is going to be abnormally hot. I always feel the suction line. So if the suction line is not even cool on a cap tube, then I know I'm not getting any cooling in the compressor. Compressors already run warm on those systems because they don't get a lot of cool gas.
That's why.
But what I will tell you is like I follow that suction line. and they keep going back further and further. It should be 6 inches off that compressor. It should be pretty cool still. If it's not getting any gas to it, it's going to be warm. So that's without gauging up to it. So
That's the same with the plug filter dryer, because that's what it is.
I'll be honest with you. If I got to cut open for a filter dryer, it's not getting a bullet, because I hate bullets. It's going to get a C something cap. Yeah. So and then with the shredder on the filter dryer, and it's going to get a whole new cap tube.
So if you're replacing
A little.
I always replace the cap tube, especially on 134, because you're just going to be back there again doing it anyway.
But you can't replace the cap tube in the.
Not in the bane table. So if you're dealing with the bane, then you're going to have to do what you got to do. What I would do is pull it out, file it off at about 1 inch, and then blow through it backwards with some dry nitrogen.
Are you talking about blow through with the,
Go through the suction,
with the cap?
pull back.
So you basically got to open up the
I
system.
don't know if you've seen this.
Yeah, no matter what, you're going to open up the system. At any given time, you need to change the cap tube. If you cannot change the cap tube, if it's welded to the line or whatever, and you can't change it, then you need to file it off about 1 inch to 2 inches in, and then and then blow back through it, through the suction line.
I want to run something by you, and I want to get your thoughts on this, not to get off on a tangent, but one important thing on a cap tube, if you guys don't know, you have to get the right amount of feet for equipment.
Well, yeah.
You can't get, if you see this much of cap tube and you don't see the rest of it, you need to make sure you get with manufacturer and find out exactly how many feet per
If
cap tube.
you're having to file off more than 1 inch, then you need to replace the cap tube. Yeah, because
My
as soon as you shorten it up, you're going to flip the compressor.
My second thing is, I don't know, Jim, if you've heard this before. I've seen a couple of the old timers do this, and I don't know if you guys have seen it, but you know the red Supco stuff.
Mhm.
You're smiling.
I'm waiting.
So this is back before I don't do it here. I haven't been on anything, and I haven't done it here in a while. But I used to put these if you had your situation that you're in, Clint. I would have stuck it in a vacuum, and I would have stuck my cap tube in some Supco, a little thing of Supco, not too much. I don't know how much protocol this is.
I don't even know what Superco is.
It's that red. Anyway.
It's like, yeah. So, anyways, I'm not saying do this, but I have done it in the past. In a pinch, I've been able to put Supco in, put the system on a vacuum, and suck that Supco up through my cap tube. I was able to clean out all that gunk, and also cleans up some of the other stuff internally. And was able to put a nice vacuum on it and fire it up.
Yeah, scratch that.
Yeah.
Do not put dye in my systems. Do not put chemicals in my system. That fix a flat crap. Do not put it in my systems. Leak, whatever it is. No foreign chemicals in our systems. So it's going to have oil. It's whatever the manufacturer spec is. It's going to have refrigerant. Nothing else. Okay. So I can't tell. I see this stuff at the shelves all the time. Maybe I'm old school, but I just like, it's been this way for 100 years, like oil, refrigerant, nothing else. So you seal your fittings, that's it. So, and you should be sealing your fittings with oil. Okay. But I appreciate it, but like I said, I can't tell you how many times I've had dye on me and I've been so stinking mad because dye does not come out. And it takes a couple days to come off my hands.
Well, it's the same, like self-sealant stuff.
So use an H10. Do not use any of that foreign stuff. If they have that, a self-contained where you put in that and it fixes the internal leaks, like you just gummed up the system. Don't do it.
You shouldn't have to use it ever. I don't think.
Yeah.
Well, I think the important thing is, like Jim said, it taints with the value of what you guys are working on. It should be oil and refrigerant.
Okay. So visually inspect the OEM provided thermometer on walk-ins, check and verify temperature with your multimeter. So your K thermometer. So I know a lot of the meters have a K thermometer on there. So where are you going to check temperature? Where the thermostat bulb is. So I can't tell you how many guys drop it on the front of the fans and like, hey, we're rocking and rolling, I'm out of here. Check what the return is coming back as. Because it may be somebody stacked boxes funky and you're not getting that. Remember, those coils are only meant to do so much TD across them, right? So if you're not getting good airflow and stuff, you're going to cause an icing situation. So the one thing I will tell you about ice is get it all off.
Yeah.
All of it. On the side panels, on the expansion valve, on the coil, anywhere that there's ice, it needs to come off because it's just going to come back.
Actually open
Yeah, you'll
both
be back
sides of the
there again.
evaporator and mush.
So let's talk about TXV bulb location. don't want to steal your thunder, but where is, he's gonna talk about TXVs, and I saw the PowerPoint, it's awesome, you guys gotta be there for tomorrow, so. But, TXV bowl location,
On the side of the section.
10 and 2. So, okay, just like,
And tight,
yeah, and tight, so,
tight.
okay, 10 and 2. You're getting a good vapor pickup, you're not getting liquid, so it's boiling off the top of the line. So if you're sitting on a horizontal, you want it at 10 and 2. I don't care where it is on a vertical.
That wouldn't be a bad idea if you guys see it like a little bit dirty in there, whatever, take some and wipe off that suction line, wipe that bulb off and stick it on there.
So visually inspect the coil for cleanliness. How many guys use flashlights to inspect? Okay, keep it up.
Do it all day long.
I can't tell you how many times I'm standing right next to a guy and I'm like, grab that flashlight, grab that flashlight, grab that flashlight. No flashlight. Yeah, it looks good. You can see that? So check discharge air temp. If I step, inspect defrost components and condensate drain. So we had a bunch of guys putting pencil heaters in at 0 zone cases. Nobody was doing anything about the damn drip time. Just adjust the drip time. Like if the OEM manufactured it without a pencil heater, you don't need one. Like go after the drip time. So there was no drip time in it. You need the drip time so that the water can get down the drain before it starts to freeze again. So make sure in our programming there's a drip time. Okay, in any freezer.
I think a lot of people also make that mistake too as well, like instead of getting into the
Drip,
diagnosis.
drip time comes from a defrost termination fan initiation clicks on. Okay, so that's allowing that water to drip before the cold air runs across all that water in the pan and ices it back up. Okay, so when you guys have those 3-wire clicks-ons, don't switch it to a 2-wire clicks-on. Use all 3 wires, because what that is it's allowing that coil to get so cold before the fans come back on. So one side of it's kicking the heaters out, the other side of it's delaying until the fans come on. So on mechanical old controls, that is our drip time.
Because if your fans are coming on too soon, it can create the drips on the top of the cylinder as well, right?
Yep. Heating cooler, check the OEM thermometer. And what I'm saying is, what do we check when we check thermometers? Okay, we check the cut in and cut out, especially with these Dixel controllers. So if you guys haven't got the specs, we'll talk about it on Thursday because we're going to go over the Hill Phoenix case because I've had a ton of questions and a ton of problems with them. We're going to go over mostly the controller settings. We're going to talk about what they mean and what they are and how they function in there and what we need, what adjustments and ranges we're going to work inside of. So it's important you guys are at that because it's very specific to that case that we're having a bunch of problems with. Because even Hill Phoenix hasn't given me hardline stuff. So we ran a couple tests. We have some data for you guys. You're going to want to be here to understand what we're doing on those Hill Phoenix cases. Okay? Because I can't tell you, it's going to be the guy that doesn't show up to that class is going to call me at 10 o'clock that morning and say, hey, I got this problem with this Hill Phoenix case. Let me guess, on the Dixel controller? Yep. Okay, let's go through this again. And then I'll send you over the PDF. Okay? So make sure we're there for that. Check the cleanliness of the honeycomb. How do we check the honeycomb? There's a couple easy ways. I flick it. If I get dust out of it, then I'm pulling it. I shine a light up in it. I carry 2 things on my hip. I carry my Leatherman and my flashlight. And I go to them all day long. Okay? If you guys visually inspect, make sure you get on the right angle and you're looking up inside the honeycomb. So I watch the guy shine a light and stand here. Yeah, that's not going to tell you nothing because the dust lays on top of the honeycomb inside. Okay. Check the airflow. If you guys want to invest in a velometer, so there's cheap ones. There's those ones you plug into your phone. I carry that for doing HVAC. It's not a good one. Invest in a good velometer. So it's worth the money if you're dealing with a lot of open air cases. So it's just, it's testing the volume of the air coming through the honeycomb. So Scott Markle will go off for a day about velometers. So make sure you buy the one that he tells you to buy because he's adamant about that when you're dealing with case performance. So your coils are high step inspect defrost operations and condensate drains. So we're checking defrost heaters, we're checking drains. What's the easiest way to check a heater? Amp clamp, right? Just throw an amp clamp on it. Throw it around the wire. So turn it to defrost, clamp the wires. If you're pulling amps and you know it's in defrost, So a lot of guys will lick their fingers and touch the heater, fine, whatever. I'll just use an I'll just use an M clamp. I like my fingertips, so.
I like to find them on accident.
Ice machines. Number one failing piece of equipment in our locations. So ice pattern. What are we talking about? The Q pattern, right? Why would the Q pattern matter? Is it going to harvest correctly if doesn't have a good ice pattern? Right? Okay. The best way to check is the ice in the bin. Pick it up. If it's too thin, it was probably too thin to begin with. If it's cloudy, it's dirty, or we have something going on with the water. It's not hardening correctly, right? So we need to check that stuff. So our ice, that's the easiest thing to check. You just scoop it out at the top of the ice and check it. Check the shape of it, check the size of it. If you're dealing with a grid style, make sure there's not chunks of the grid. It's supposed to hit the diffuser and shatter into all individual ice cubes. If it's coming off in a grid, that's an adjustment. Okay, you need to adjust the cube thickness probe. Don't just say, oh, well, they'll break it up when the agitator goes through and does it. That's not what the agitator is meant to do. The agitator is meant to move it to the chute and dispense it out the ice machine. It's not meant to break up the slabs of ice that it's dropping. So, okay. Perform a production test. How do we perform production tests? What things do we need to do a production test? Water temp coming in, inlet temp. Why is that important?
Because if it ain't hitting 32 degrees, it ain't gonna ice.
Well, no, it's water inlet temp. So coming from the city.
Okay.
Okay. So when we do a production test, we're going to test that inlet water temp. What that's going to tell us is how, if it's lower than 72 degrees at the factory, we're going to do a little bit, we're going to perform a little bit better. But if it's too low, below 57 degrees on a Hoshizaki, it's going to ice up the evaporator. Okay. So we need to test that inlet water temp. So what else? Other ambient. Okay. Because this is what Hoshizaki or Manitowoc or anybody's going to call us about. They're going to say, okay, I want you to do a production test. I need these things. I need your suction, I need your discharge, I need your water temp, and I need your ambient temp. Okay? Because when it's 110 degrees outside and the side of that building was 140, which we saw in Bullhead City. I've got a 1,600 pound machine and I got 96 degrees water coming in. Is that still a 1,600 pound machine? No, it's not, because I had to reject all the heat out of that water to get it to 72 degrees, all the heat out of that air to get it to 70 degree air, and then I could start down. Okay, but the machine had to reject all that ambient heat and water heat first before it could even start to get to that number that they've engineered it in the factory at. If you guys are dealing with a low production store, you have really high temperatures, then you're not producing what the machine's meant to produce. You might be producing 2/3 of that. Okay. The second thing is, and that's why when you weigh it in, right? So I can do a production test now remotely through our system because I know water temp, I know the ambient temp and humidity, and I know what the pressures are running, and I can count the cycle time. Because I know as soon as I go into harvest, as soon as that comes out of harvest, I can tell you if it's a 26-minute harvest or a 26-minute freeze and a 4-minute harvest based on what I can see on the pressures. So we can do that with our system. So we did it that way on purpose because I can't tell you how many times customers call us up at a C-store and say it doesn't make enough ice. And I don't want to drive all the way out there to tell them it's doing everything it can. I'd rather just be able to look at the graphs and tell them that based on the data I get. Okay?
Putting that in the shade help that?
No, because the compressor's only going to reject and absorb the heat or reject the heat or compress the heat that is being absorbed through the evaporator and rejected through the condenser. So there's a little bit of ambient heat, but all the heat that compressor is dealing with is the heat of compression that's coming from the evaporator. So it's taking all that heat in a big space and it's compressing it into a really tight space, and then it's trying to send it up the discharge line. So, and starts to de-superheat. It doesn't even start to superheat until it hits the condenser. So that's why, I mean, it can be cold outside and that compressor can be hot as a firecracker because it's not, something's not, either it's not condensing right or it's overcharged or the fan's off in the condenser or whatever. So you guys, so the compressor, the ambient air around it matters. That's why they run hotter in the summer, but it's more the heat that's not being rejected off of the condenser because of the air outside than it is the heat around the compressor. Shut water off and let the evaporator dry to inspect cleanliness and condition of the evaporator. So we've talked about this a lot. So, and the reason why we talked about it a lot is without fail, a guy shuts the water off. That looks good to me, turns the water back on. It's still wet. The calcium in that evaporator is not visible. So the contaminants on that evaporator are not visible when it's wet. So I once had a manufacturer tell me to blow dry it. I'm like, well, I don't carry a blow dryer in my truck. So I guess I'm gonna throw that in the arsenal of tools. One blow dryer. So if you have a heat gun or something,
Will that be a truck stock item?
yeah. So, and then verify that water flow meets requirements. I think it's 20 psi for Hoshizaki. I think it's pretty much saying no lower than like 8 for Manitowoc and stuff because of it's a slow flow. So Manitowoc gives their machines like 4 or 7 minutes, I can't remember, to fill and then refill, and then it shuts off. So you know how it fills, and then it'll run down a little bit, and then it'll refill up to like 7 minutes, and then it's done filling up. So that's how they run an undersized trough. They'll run an undersized trough, they'll let some ice fill on the machine, and then they'll fill it again. So air conditioning, air filters, check date and initials, no older than 90 days, check blower motor and belt. Talk about blower motors and belts. So let's talk about blower wheels too. Okay, I've been out a bunch this last little bit, and I don't know why it's not happening, but I'll go out and look at a blower wheel. Blower wheels have little scoops on them, right? What happens when you fill those scoops with dirt? Make them flat.
How you doing? Good morning.
It drops down the CFM, right? So what's that going to do to the performance?
All right,
of the
I need a
So when we're
text me a
cleaning these,
PO.
we need to clean that blower wheel too. We need
stay on
to
the
visually
clock,
inspect
go
out
to
with a
the gas
flashlight.
guy
We
and
need to
pick
clean
up
out
the
those
wheel.
things. Okay.
So I
Second thing
use my
is
last
belts,
wheel
right?
over here.
If
Make
belts
a little extra
glazing
money and stay on the clock.
or cracking,
But I'm gonna stay
what
on the clock
causes
to
that?
pick up some wheels for these yard houses. For these
Excessive
drawers.
heat, right? Friction, more than the belt's rated for. Okay, so if we're changing belts more than a year, right? Something's going on. There's excessive heat.
And is there anything else?
So it's not adjusted properly. Check the shiv. The shiv is used and not beat, and you're not making good contact on the belt. That belt, all through that rotation, is slipping on that shiv. Okay. So you guys need to check that. Check the alignment.
Thank you.
I've seen it where the shivs are like this. So it's rubbing against this side on the inside of the belt and on the outside of this side as it's running through both sides of that shiv. Okay. On train and carrier, what kind of belt should we be using? Cogged. They spec cogged belts. Do not use a regular A belt. So you get a little bit more play in cogged belts, you get a little bit of cooling through the cogged belt, and you get a little bit more tolerance. So make sure that we're using the spec belts for those. Inspect condensate drain pan for cleanliness and proper draining. We're finding a lot of this right now. So how many of you guys are pulling the P-traps off the HVACs at Maverick and knocking them on the ground? If they're glued, replace them with one that you can pull off and clean. Okay, they're not supposed to be glued. So if they're broken, replace them. So if you guys don't have a P-trap and you don't create that seal, right? What happens to the water in the drain pan? There's so much volume and air movement inside that unit when it's sealed up. If you don't have a P-trap with water in it, causing that seal to happen, it will not drain. I've actually had it happen multiple times where there's no drain. I'll shut the unit down and watch water pour all over the ground. And they called me about water dripping through the vents. And all it was a P-trap was missing. Okay? It causes a vortex within that drain pan because of the velocity of that airflow, and it causes that unit not to drain. So inspect outdoor aluminum filter on the economizers when used. I can't tell you how much that's missed, guys. Make sure, I don't care what time of year it is, we don't know when the economizers are going to open and shut, but if that filter's plugged up, it's inefficient. So let's just make sure that they're clean. Get up underneath those economizers. It's that aluminum mesh filter. If it's tore up, replace it. If it's gummed up, take some New Bright and wash it. New Bright gets that aluminum nice and clean. So put it on the roof, put it down, depending on what roof you're on. You can't use chemical on Costco. So make sure you take it down to the concrete and wash it off. Okay? If you're at a Maverick, you can just do it when you're cleaning up there. But take it downstairs, hit it with some New Bright, foam it up, wash it, and then put it back in. Cold wall chill rails, visually inspect frost patterns, amount of frost, check defrost components. So that's kind of funny that they're talking about defrost components and chill rails because usually there's not. So we have been putting them in at night. So the best thing to tell you about chill rails is understand the behavior patterns of your customer. Do they unload it at night? If they do, and they don't want to pull it every 2 weeks and shut it off on Sundays, then we can help them out with a defrost cycle. If they pull it at night, then we can put a timer in there and we can put it on like a 4-hour defrost. And that's what we've been doing. So, but if they never pull it, well, then they're just going to have to do it the old-fashioned way and shut it down every once in a while. So, inspect all evaporators for proper feed patterns and cleanliness. If you're dealing with a distributor, like on the low boys, how they distribute to both sides of the coil, make sure that the bulb mounting is on the suction line. I've seen it where it's, I've been talking to David Burns as well. We're seeing a lot of them where they mount it right in between the 2 evaporators. So go 6 inches off the trap, by the trap, mount the bulb. Don't have it mounted inside. Have it mounted after the 2 coils where the 2 suction lines come out and hit the same common suction line. 6 inches off the last connection is where I want my superheat set reading. Inspect all fan motors, blower motors for proper operation. Inspect and verify all defrost components. Heaters, click-on switches, defrost, turbination, and time clock. Inspect all condensate drain lines for proper draining and cleanliness. Make sure all belts and filters are good. So when you guys are doing belt inspections, make sure if you have a gloss belt, that's a bad belt. It's just time before it heats up and breaks. Just because it ain't cracking, it's going to bark, it's going to drive the customer crazy. So if it's glazed, so a belt should look opaque, meaning dull, shouldn't have any sheen to it. So, and make sure if you guys are coming up on units where we're taking over a new building, which we've taken over a few this year, every time I go up there, I rip all the A belts out of there and I put in cog belts. Okay? That instantly makes me a better contractor than the last guy. See how easy that was? I got to get belts anyways, might as well buy an AX. So, any questions? His ears are smoking. Just kidding. Okay, thanks guys.